The square root of -1 equals I. So, since this is the case, this is a fact with complex numbers, so remember this, then we can also say if we were to square both sides, then we can also state that I squared equals -1. So, with that being said, we're going to go through the list of I properties. So, if we know that I squared is -1, then let's backtrack once and say, okay, well that means I to the first power is I. We know that because anything to the first power is the same number. So we know now that I squared equals -1. Okay, so then if we do I to the third, this would be like putting I squared together times just regular I to the first. Because if you use the multiplication property and you add the exponents together, you're going to get I to the third. So, since we know that I squared is -1 and I is I, then we know that I to the third equals -I. Alright, so then I to the fourth is like saying I squared times I squared. And since we know I squared is -1, then we have -1 times -1, so we know that I to the fourth is 1. So, it's really important that you memorize that little chart right there, and I'm going to rewrite it right now so you can get a little picture. So you need to know that I to the first is I to the second is -1, I to the third is -I, and I to the fourth is +1. Now the reason why you only need to know those are because if I asked you any other combination, so let's say I asked you for I to the sixth, well, that's like putting I to the third times I to the third, which is -I times -I, so we're going to get positive I squared, but then we can break that down further and say, okay, well, I squared is -1. So I to the sixth also equals -1. So any other number, or excuse me, any other exponent higher than 4 is going to be one of these choices, I, -1, -I, or 1. It follows a pattern. So an easy trick to know is, say I gave you I to the 25th. Well, instead of like breaking that down into all of these I properties, I'm going to say, all right, well, in your calculator, just do 25 divided by 4. And when you do that, you get 6.25. So this means, so if I have a chart of 4 numbers, each one is going to be 0.5. So then I'm going to have, okay, well, this is the first one out of 4. This is my second number out of 4. My third number out of 4. Sorry, wrote that a little high. Second number out of 4, my third number out of 4, and my fourth number out of 4. So, if you wrote this as a decimal, you'd have, up top here, you'd have 0.25, then you'd have 0.5, 0.75, and this is going to be any whole number because this is 1. So, what I mean is since it doesn't matter that it goes through 6 times, so it's going to go through the cycle 6 times, and then it's going to stop at 0.25. So that means I to the 25, since this is my 0.25, it's going to equal I. Let's look at another example because I know that was a lot. So if I said I to the 67, then 67 divided by 4 is 16.75. So that means it's going to go through that cycle 16 full times and then stop 3/4 of the way down. So I to the 67 equals -I. If I did I to the 122. This equals 30.5. It's going to go through that cycle 30 times and stop halfway down, so we're at -1. So we can pretty much figure out the value of any I to any exponent value. So you just need to divide by 4, but you have to have those 4, I to the first, I to the second, I to the third, and I to the fourth memorized. You have to know that. Honestly, you don't really have to memorize them. You just have to know that I to the first is I, which you should know, and then I squared is -1. Because then, with I to the first and I to the second, we can create I to the third and I to the fourth. Alright, so let's look at some complex properties. Complex numbers have a real part and an imaginary part. So, this is the general form, a plus bi. A is going to be our real part, and bi is our imaginary part. So any number that's next to I is considered the imaginary part. So here are a couple examples. 4 plus 3i. So 4 is the real part and 3i is the imaginary part. Or you could have 6 minus 2i, where 6 was the real part, 2 was the imaginary part. If I just had 7i, then that means that the real part's 0 and my imaginary part is 7. It's also important to know that the real part comes first. That proper form is that you have the real part and then plus or minus the imaginary part. Just like other functions, we can add and subtract imaginary numbers or complex numbers. So, for example, if I gave you 3 plus 2i plus 4 minus 5i, just like terms way back in Algebra 1, you're going to take the real parts and add them together to get 7, and then you're going to take the imaginary parts and add them together to get -3i. So this is my final answer for that one. Now if we were to subtract, if I had -4 plus 8i minus 6 minus 4i, the first thing you need to do is distribute the negative, and then we can rewrite it as -4 plus 8i minus 6 plus 4i. So now we just add like terms, -4, -6, so I'm going to get -10, and then my imaginary part, 8i, and positive 4i to get 12i. We can also multiply complex numbers. So if I had 3 minus 7i times 5 plus 9i, just like if it were an x, we're going to double distribute or FOIL. 3 times 5 is 15. 3 times 9 is 27i. -7 I times 5 is -35. And -7i plus 9i is positive 63. Oh, I'm sorry, it's -63. -63, but I times I is I squared. We will have to change that in a second, but the first thing I'm going to do is combine those middle two terms. So positive 27 minus 35 is going to give me -8. So now I have 15 minus 8i. Oh, I forgot my I in this problem right here. 35i. Alright, so 15 minus 8i minus 63i squared. But what is I squared? We know that. I squared is -1. You cannot have I squared, I to the second, I to the fourth in any of your answers, because at the beginning of this video I showed you how to simplify them into either I, -I, 1, or -1. So the highest degree you can have when working with complex numbers is just I to the first. So this is going to become 63 times negative 1. So right here, it's going to change 15 minus 8i plus 63. So then we have 15 plus 63. It's going to give us 78. We're going to write that first because our real part comes first, and then minus 8i. So this is our final answer after multiplying. One more example of multiplication. If I gave you 2 plus 5i times negative 1 plus 2i, and I FOIL, I'm going to get negative 2 plus 4i minus 5i plus 10i squared. So my middle two terms combine to give me negative I, and then I have 10 times negative 1 because I squared becomes negative 1. So I'm going to have negative 2 minus I minus 10. So my final answer is going to be negative 12 minus I.